Actually, this session is about electricity. So when we actually talk about electricity, the very first thing that comes in our mind is electrical current. So then it also actually gives us a feeling that it is something about the charges. Okay. So then the basic thing of this actually, you can say the chapter is the Ohm's law. What Ohm's law is, let me give you a very simple understanding. So about the Ohm's law, is any one of you already knows about Ohm's law? Anyone? You can raise your hand or just unmute your mic and you can speak if you know about Ohm's law. The statement of the Ohm's law is that the current is directly proportional to potential difference. Okay, now you people must not worry about these all kind of statements because we will actually understand them one by one. And Yaran said, yes, exactly. That is actually the statement. Now, here you see that what I wrote here. I wrote here that current is directly proportional to the potential difference. So mathematically, this we can write as potential difference V that is proportional to electrical current, meaning these two parameters are directly proportional to each other. And this sign here is the sign of proportionality. So this actually mathematical equation tells us that both potential difference and current are directly proportional. This means if you will increase the potential difference, current will increase. If you will decrease potential difference, current will decrease. What this kind of equation we do not use in mathematics to solve the problems mathematically, and we have to change our this proportionality sign into equality sign. When we change this proportionality sign into equality sign, we always need a constant of proportionality. So potential difference is equal to resistance times current. Now, here R is what? The resistance. If you actually, you can say resistance, if you remember correctly what words I used that this is also in this equation is a constant. So this means that when current and the potential difference and current are directly proportional, they are changing with each other, then this resistance must be constant. This resistance must be constant. So if resistance is not constant, then Ohm's law is not there. So Ohm's law can only and only work if resistance is constant. So this is the key for the Ohm's law, that if the resistance is constant, then our Ohm's law will work. Otherwise, it will not work. But now here we have actually three parameters: potential difference, resistance, and current. So let's understand them one by one. So first we start about current. What current is? That it is the flow of electricity. Flow of electricity. Now, we are actually going to understand the true meaning of the current. When we say this is the flow of electricity, that statement is for simple people that actually have no much knowledge about electricity. But you people are actually now like Einstein and Newton for me, my master Shifus. So we will actually give the more accurate definition. And when I say current, for example, I have an electrical wire and I say that there is current. Then it means that you can say in a very simple word that electricity is flowing. What that means? That means actually that the charge is flowing. Charge is flowing. Okay. And we measure the current in the units of ampere. So we write it as A. For an example, I say that I have a current I, and that current is 2 amperes. What this 2 amperes tells us? So it actually tells us in a very simple words that the current is the rate of flow, rate of flow of charge, rate of flow of charge. So what does this mean? This means that it is telling us that how much current is, sorry, how much charge is flowing. What current tells us? That how much charge is flowing in every second. So then when I say that current is 2 amperes, it means I am telling that the 2 coulomb charge is flowing in every second. So our definition of the current is the charge over time. Charge over time. So this is what we call it, that this is the rate of flow. Rate of flow. In the same way as we actually, for example, go a little bit back to the motion chapter where we actually define the speed and the velocity, that it is equal to the distance over time, that this is distance over time. So distance over time, when we are dividing with respect to time, it means it is a rate. It is rate. Rate means that how fast or how slow something is changing with respect to time. Okay. So now here we understand that our current is the rate of flow of charge. Rate of flow of charge mathematically is charge divided by time. This is what the current is. Okay. Now, current has been defined. If then we go to the next thingy to understand, and it is a resistance. What is it? It is resistance. What resistance is? Anyone? Good. What you said? The force, is it?
Yeah, force against the current.
Forced against a current. Very good. Very good.
Thank you.
So, thank you very much. So, now again, this is actually, you see, when you use this term, you say force, then it means that the resistance must come in the units of Newton. In the units of Newton. But this can be true in mechanics, where we actually say that we have a air resistance. Air resistance, meaning that it is actually the force of the air in against the motion. Okay, that can be in the newtons. But in case of the electricity resistance against the electricity or against the current, that we will simply say that this is our opposition against the current, because this opposition is actually not in terms of the Newton. It is actually measured in the units of ohm, in the units of the ohms. For an example, that if I say that I have a resistor and its resistance R is 100 ohms, it is resistance is 100 ohm, then it means that to have 1 ampere current, 1 ampere current, we need 100 volts. Okay, because from this equation, this is Ohm's law equation, we can see that the resistance is equal to this current will divide the potential difference. That potential difference divided by the current, that is the resistance. Okay, so resistance is equal to potential difference divided by current. So this will be 100 if I have 1 ampere here, 100 volts, meaning that you need 100 volts to push 1 ampere current into any wire or any element that has a resistance of 100 ohm, meaning these many volts against each ampere. These many volts against each ampere. Got it? So then we can say simply that the resistance is the opposition in the flow of current or opposition against current. Very good. Thank you very much. Now we move towards our this last definition, and then we will understand this Ohm's law. And then I will move you guys towards the circuit to understand this in more details. And the next definition is what? The potential difference V. This V, we call it potential difference. Potential difference. And we measure it in volts. What? Volts. So we actually use the symbol V as well for the units. Okay, now very much. So remember one thing about the potential difference. Potential difference tells us about the energy against the charge, meaning energy divided by charge. Okay, for example, you go to the market and you buy a battery and its potential difference is 1.5 volts. This is a one dry cell. So this 1.5 volts, it tells us that you can provide using that dry cell 1.5 joules of energy to each coulomb of charge to flow through the circuit. Okay, so here the two things that you must remember about the potential difference. Number one, that the potential difference tells us that it is energy against each coulomb of charge, meaning that it is the energy provided by the battery to each coulomb of charge to flow through the circuit. And the second point that we need to remember about the potential difference or the voltage is this word potential difference. As you already told me, that it is actually in the circuit, it is actually the difference of the potential between 2 points. So the potential difference is always the difference between 2 points. Okay, good. Now, if you actually understood these three things along with the Ohm's law, that is the main basics of this chapter. So on these bases, we can build whole chapter very easily. So now, once again, the Ohm's law. What Ohm's law is that the current is directly proportional to the potential difference. Meaning that if the question they asked in the exam that state Ohm's law, so this is the best and the most accurate definition or the statement of the Ohm's law, that current is directly proportional to potential difference. And we write it mathematically that the potential difference directly proportional to the current, and then here we actually converted the proportionality sign into equality. So we got the constant of proportionality, which is resistance, R. So V is equal to Ri or IR. And then we define the current. The current is the rate of flow of charge through any, you could say, the conductor. Conductor means the material through which electricity can flow. So that is the conductor, mostly the metals. So if, for example, we have a current of 2 amperes, that means 2 coulomb charge is passing through a wire every second. And the resistance is the opposition against the current. Opposition against the current. And its units are ohm. For example, if we have 100 ohms, then it means we need 100 potential difference to push 1 coulomb, to push 1 ampere current through the circuit. And then the potential difference is energy over charge. Potential difference is equal to energy over charge. So you can also write it potential difference V is equal to energy E over charge Q. Okay. Now I'm going to draw the circuit. What is it? Is the battery. It is the battery. Okay. So this is the battery. So this battery means that what we do, we put a small line, big line, and then these two terminals, these wires are connections. So this is one single cell. As I gave an example of 1.5 volts dry cell, when we buy a small cell from the market that looks like this, it is mostly 1.5 volts. Okay. And if, for example, it is a battery, and you may remember that if you go to the market, so you can buy this kind of battery from the market that looks like this and over here. So it can be even 9 volts or the 12 volts. So now if it is 9 volts, then it means that what we have 6 cells are there, and then we draw the battery like this. Sometimes we do like that, or sometimes we actually also draw like this. What one side should be the smaller terminal, other should be the bigger terminal. Smaller terminal is the negative terminal, and the bigger terminal is the positive terminal. Okay. Smaller terminal is negative, bigger terminal is positive. So this is our battery. You can say this is a source of potential difference. So you people must also mind my each and every word when I'm speaking because these are very important. So the potential difference. So smaller side is negative terminal, bigger side is the positive terminal. And now what I have here this kind of a rectangular block and again these two wires. What is it? What does it mean? This means resistor. This is a resistor. So resistor means that it is an element. It is an element which will provide resistance in the flow of current. Okay. Then what I do, I connect this battery with a meter, and this meter is mentioned like a circle and a A in it. So this meter is what? Ampere meter. Ampere meter. We also write, but we write it M meter. M meter. Okay. Or ampere meter. M meter or ampere meter. So with this name, it is very simple, straightforward that this meter will actually measure the current. What would it actually measures? It measures the current. Okay, so I will be measured over here. Then now I have connected with this resistor. And then I took this battery and I connected the positive terminal of this battery and connected it with an element which looks like this. What is it? This is a switch. What is it? This is switch. If I put it down, so it will be connected. Right now, this switch is open. It is not closed. And then over here, I have an other box. This box is like this. And then here, I'm connecting over here. You can see both boxes are the same. Then both must be the resistors. But this resistor has an arrow on it. If there is an arrow on this box, which is a rectangular box, meaning it is a resistor, but a resistor with arrow, that means this is a variable resistor. Variable resistor means that we can change the resistance. We can change the resistance of this resistor. Okay, very good. So now this is our circuit. But we are still missing one element that I will connect over here. And this is another meter. And this meter is over here. And we have here, this is the V inside this circle. So this means this is a voltmeter. What is it? Voltmeter. And voltmeter, what voltmeter would measure? It is simple that the potential difference V. Okay. Now, this is our very simple, straightforward circuit. But before going to actually, you can say, do an experiment using this circuit, we need to understand each and everything of this circuit because this is all are the main basis of this whole chapter. If you people understood this, you people understand each and everything of this circuit, this chapter. Now, here I connect this switch. Now, this switch is closed. This switch is closed means that now the current can go through this circuit. Very first thing is current, that in which direction the current will be flowing. Now, what I have here a slide. Okay. So this slide is like this. Okay. So this is the slide. And here we have.
Sorry, I have a question.
Yes.
You mean by negative to positive, you are saying like starting from negative and finishing at the positive side?
So this is what actually my class is telling me, that the current should go from a negative terminal and then flowing through
Oh.
all the circuit and coming back like that.
No, then I'm changing my answer. I was trying to say positive from positive to negative, like starts from positive and finishes from the finishes at the negative side.
Why? Reason?
Because I thought like it should start from the positive side and like go and finish at the negative point.
Any reason?
No, I just
No
think
reason.
like that. Yeah.
No. Okay. Good. Now I am putting you on this slide. Okay.
Mhm.
If you are here, would you go down or up?
Down.
Down. Okay. And if, for example, you are here, can you slide up automatically or not?
Not.
No.
Yeah.
Then, reason that this is higher, is it?
Yeah.
And this one is lower, is it?
Yes, it is.
Very good. You see, nature is going from higher to lower, isn't it?
Yeah.
Yeah. So, this positive is actually the higher potential. This is higher potential, and this negative is lower potential. So that's why we are calling it negative. And positive means higher potential.
So we'll go from the positive to negative, right? I'm right.
Excellent. Yes.
Yeah. Okay.
Yes, it is. Because now we also have a reason that actually why is it going from positive to negative?
It's easier.
Yes. No. It's not easier. It is actually, you see, that the charge will go from higher potential toward the lower. It is the sliding of the charge particles. It is the sliding of the charge particles. But here, I will take you in later on when we will be almost at the end of this chapter to actually say that this statement is really something very careful statement. That the charge particles, they go from higher potential towards the lower potential. From higher potential towards the lower. Positive is higher, negative is the lower. Okay.
It's a kind of like law of the nature, right?
You can say this, yes, because this is actually on the other hand, because another thing is that, for example, here it is actually, you can say the energy is larger. Energy is larger. Okay. So a particle at this point has a higher energy than here. The particle has the, you can say, the lower energy. It has a lower energy. So now, of course, that this particle will be more active, isn't it? It has more energy. And we learned the potential difference is the energy per charge. Energy divided by charge. That is the potential difference. So the potential difference tells us that how much energy in joules we can give to 1 coulomb of the charge to flow through this circuit. Got it? So that is why it will go from higher potential toward the lower potential. Energy is more of the particles. That means they will definitely go towards the energy where it is low. Got it?
Got it. Thank you.
Very good. Now, the second point that we need to understand that when current actually going like this, it arrived here at negative terminal. Here it never terminates. It goes through the battery. It goes through the battery, and this circuit is complete, and it is running in the circle. Okay. So we call it a loop. Okay. Because this battery taking the charge particle from this terminal, putting them again here, taking here, putting them here. So you can say that when the charge will lose its energy by arriving at negative terminal, battery will giving them additional energy, which was its chemical energy, because battery converts chemical energy into electrical energy. So then battery will actually add up again, recharge the charge, and the charge is here again running, coming here again running. So it is will be continuously running until this switch is closed. Very first thing. Now, good. The second thing which I want you guys to know that here, when the current is actually flowing through this circuit, then, for example, the current arrived here at this point, because here current has only one path. It passes through this resistor. It is coming over here. Now, at this point, look at this point very carefully. Before this resistor, the current can go through the voltmeter and also through this resistor. But this voltmeter, it is supposed to measure only potential difference. The voltmeter is only supposed to measure potential difference. So the current must not go through this potential difference. The current that we generated with this battery, it must go all of it through our this resistor, because this is our main element. This is our main element, because we want to test the Ohm's law that the potential difference is equal to resistance times current, because we want to tell how much potential difference is across the resistor, this resistor R, and how much current passes through this. Got it? So that is why this voltmeter is across this resistor, and this voltmeter is in parallel. Why parallel? Because potential difference is always between 2 points. Potential difference is always between 2 points. So that is why we are connecting this voltmeter across this resistor at these 2 points in parallel. And then the current must not go through the voltmeter. This is our task, that current must not pass through the voltmeter. So then in that case, what we should have, we must have a voltmeter that has a very high resistance, very high resistance. So the resistance of a voltmeter is too large always. This is true. So then current will not go through the higher resistance because there is more opposition. So it will go through this simple resistor which has a lower resistance. Okay, good. Now current came over here. Then there is a ammeter. Current, how we define the current? We said the current is equal to charge divided by the time. Okay, meaning that how much charge in coulombs, how much charge is passing every second. Of course, this you will tell at one single point. For example, this is if you want to tell that how much current is passing through the circuit, you can sit at one single point and you can measure it, and you can sit at any point or wherever you want to measure. Wherever you want to measure, you will sit at one single point. So that is why we put this ammeter like this at a single point, and we call it that this is in series. It is in series in these all in this circuit with all elements. Okay. So if this is in series, then now you can raise a question. You can say that Shabazz, here, this current will feel some resistance because of this meter. That is not good because it will reduce the current, which is the current produced by the battery. So it means battery is producing more current, but this ammeter is reducing it itself because it will also give some resistance. So that is why what we do, we use ammeter with very small resistance. So what we learned here, that when we use the ammeter has very small resistance. And when we use the voltmeter, we use a very large voltmeter, and voltmeter is always in parallel. Okay. And ammeter is in series. Got it? So this is actually the simple circuit how we design. But this is our simple understanding of the electrical circuits. When we put these kind of elements, that what happens, the current goes from positive terminal toward the negative terminal, and it will be continuously flowing through this circuit in the loop until the switch is closed and battery is alive. And then we put the voltmeter in parallel across an element across which we really want to measure the voltage, or we want to measure the potential difference. An ammeter that we put it in series, Good. Now, any questions so far with this understanding? What potential difference tells us? That how much energy in joules per coulomb charge, meaning energy divided by charge, and current is charge divided by the time. Good. Here, now, what we can do, we can actually understand the Ohm's law with this circuit. That was our ultimate goal. Okay, now for that, we need to actually also draw a graph, and we need to understand the graph as well. Okay, here we have our battery. This battery has some potential difference, and this potential difference can be, let's say, 9 volts. This is just for an example. Okay. When this potential is 9 volt, that means that this positive terminal is at a higher value and this negative is at lower. For an example, I'm saying again example, meaning that if positive 9 volts here, then at a negative terminal it will be 0. So 9 and 0 difference is 9 volts. So this is the meaning of the potential difference. Okay, now this higher potential value is here, and it will also be positive 9 here. Then this 0 is here. This ammeter has almost a very small resistance. So we would say that nothing will drop across this ammeter. So potential will be over here, and that will be 0. Now you see, if I would say this is the point A, this is the point B. So this is very, very important understanding. If this is a point A, this is a point B. Point A and point B, it has two resistors. Okay, it has two resistors in series. The potential difference between A and B is 9 volts, because this is 0, this is positive 9. Now here you can see that actually that's this 9 volts potential difference of the battery will be actually shared between this resistor R and the resistor RV, that is the variable resistor. Okay, so now here listen this again very carefully, that the potential difference which we are providing through this battery, and the battery is a 9 volts battery, and this potential difference will be divided between these two resistors, because these resistors are in series, and this point A and point B has a potential difference same as the potential difference of the battery. So this will be shared between these two resistors. Now remember, as big the resistor, as big the resistor, as big the potential difference. For example, if this variable resistor is too big, if this variable resistor is too big, then its contribution will also be too big, meaning that it will take more voltage compared to the voltage across this R. So we are using this variable resistor here in this circuit just to change the voltage across this small R. Okay. Now consider, if we do not have this variable resistor, then all of the 9 volts of the battery will go to this main resistor. Good. So you can say that actually we put this variable resistor just to change the potential difference across this R. Because why we did this? Because we want to actually understand the behavior of this resistor. And to understand this behavior, we need to plot a graph. And then x-axis has a potential difference. The potential difference along the x-axis is the V, like this. And then the y-axis is the current. Now, what will happen? When we will be reducing this value of the variable resistor, then more voltage will appear over here. And when we increase the voltage across this variable resistor, so then less voltage over here. Now, what would you see? That with this circuit, that by increasing the potential difference, the current will also increase, and it will be increasing linearly. So straight line, straight line. So this straight line, if you remember in mathematics, we have the equation of the straight line y is equal to mx plus c. C is y-intercept, m is the gradient. So do you know this equation? Y is equal to mx plus c. Okay, don't worry. Then I will not go through this equation to explain you. So then this actually, the mathematical equation, this Ohm's law, it will give you that as much voltage you are increasing, as much current will be increasing. As much voltage will be increasing, as much current will be increasing. And then you will have this straight line, this straight line. This straight line means, what is the meaning of this straight line? This straight line means actually that the resistance of the resistor, resistance is constant. Resistance is constant. Now, you remember that we said that the potential difference is directly proportional to the current, which is Ohm's law, and potential difference is equal to resistance times current. And this R was constant of proportionality. So that is why if this straight line is there, this straight line is telling that the potential difference and current, they are directly proportional to each other, and resistance is constant. Resistance is constant. So if resistance is constant, then we would say that is an ohmic resistor. That is an ohmic resistor. Got it? That the resistor is ohmic. When we say ohmic resistor, that means the resistor follows the law of the Ohm. Or you can say the resistor follows Ohm's law. So that is why It is a straight line. It is a straight line passing through the zero. So that is omega. Good. Any questions so far? No? Then I draw another curve before we end our lesson here. So here, for example, I have this kind of a behavior. And on the negative side, it is this kind of behavior. So what is happening? So this is not linear, isn't it? So first of all, you can say this is non-linear. If this is non-linear, that means, first of all, it is not omega. What is the meaning that it is not omega? It means the resistance is not constant, meaning that the resistance is changing when we are pushing the current through the wire or through any element. So now you see, we are increasing the potential difference. Initially, current was increased fast, then it is increasing slowly. It is not increasing anymore. If current is not increasing faster, or it is increasing very slowly. So what does it mean? It means that there is more and more resistance, isn't it? That there is more and more resistance, which is actually causing the decrease in the flow of current. So this is the example of our heaters. When we switch on the heater, what happens? That the temperature starts to increase. When temperature will increase, resistance of the wire will increase. Okay. So then we would say that this behavior is a non-ohmic behavior, non-linear behavior, and this is the behavior of a heater, or you can say a filament, or a filament bulb. A filament bulb. So this is the behavior which is non-linear, non-ohmic. Non-ohmic means resistance is not constant. Non-ohmic means resistance is not constant. Got it? So this is the simple understanding of, you can say, the basics of our this section of electricity. We will actually have still a few more topics to discuss conceptually. But next time, if we get the opportunity, we will actually go through the questions. Then we will solve some questions for better understanding together. Okay, any questions so far from